Suppose now we have a region that is bounded by the two curves f and g on the interval a, b. If we take the enclosed region on the interval a, b and rotate it about the x-axis, we will obtain a solid. To find the volume of this solid, we slice the solids perpendicular to the x-axis. The cross-section is a disk with a hole in the middle with the thickness being delta x. This is called an annulus. To find the volume of this disk, we first find the area of this cross-section. If little r is the inner radius and the capital R is the outer radius, then the area of the cross-section is pi r squared minus pi little r squared. The volume is the area times the thickness, but the area is pi r squared minus pi little r squared times the thickness delta x. The volume of the entire solid is the total volume, which is the sum of all of these little volumes, V sub I. But V sub I is pi capital R squared minus pi little r squared times delta x. Since x is the variable of integration, we express the outer radius and the inner radius in terms of x. They are function of x because we slice the solids perpendicular to the x-axis. Thus, we obtain the volume as a definite integral as n goes to infinity. It is the definite integral from a to b, pi times the area of the slice or the annulus dx. We now summarize the results of the volumes of solids of revolution. It is the definite integral from a to b of a of x dx, or from c to d of a of y dy, where a's of x and a of y are the area of the cross-sections. If the cross-section is a disk, then the area of the cross-section is pi times the radius squared. If the cross-section is a washer or an annulus, then the area is pi times the outer radius squared minus pi times the inner radius squared. If we slice the solids perpendicular to the x-axis, then the thickness is delta x, resulting the variable of integration is x. Therefore, we need to express the area of the cross-section in terms of x. If we slice the solid perpendicular to the y-axis, then the thickness is delta y, and so we express the area in terms of y. These are known as the dish or the washer method.